Diffraction of the waves through an aperture. Diffraction of water waves. Consider the ripple tank arrangement. Let the tip of the needle, which is connecting the electrical vibrator, which produces circular wave front, be S. These wave fronts would be traveling in the direction along P. Let X and Y be the two vertical glass plates immersed in the tank, far away from the vibrating source, such that there is a gap between them. The plane wavefront MN formed would be incident in AB, where AB act as obstacle. Any opening, such as AB, is called an aperture. You would think that only some of the light would pass through aperture AB, but we will have a different situation here. The circular wavefront which passes through the AB aperture results in a higher number of wavefronts which are circular in nature and will be spread out in all directions. The waves emerging from the aperture AB would deviate from the original path P and would travel along the directions such as Q and R shown. This deviation from the original direction of light and formation of a new circular wavefront is due to the bending of waves. This phenomenon is known as the diffraction of light. The bending of a wave, or the deviation from the original direction of light wave, is known as the diffraction of a wave. Diffraction of light waves. The wavelengths of the light waves are very similar to the wavelengths of the water waves, when compared with each other or when compared to the wavelengths of sound waves. Therefore, the diffraction of light requires small-sized obstacles for observation during the experimentation. The bending of light waves around an obstacle whose dimensions are comparable to the wavelength of the light, which is incident and hence spreading to a shadow, is called diffraction. Diffraction of waves as a straight edge. Water waves. This concept can be understood with a slight change in the obstacle which is placed in the ripple tank. Let us place half a meter scale in the ripple tank such that its length is in contact with the water surface, but width perpendicular to the surface. This type of obstacle is called a straight edge. Here, A is the tip of the vibrating needle and behaves as the source of the waves which spread out and travel towards the scale BD. The waves spread out equally in all directions until they reach the straight edge BD. At this point, if there is no bending of the waves, the lower portion of the circular wave fronts should be cut off completely. Only the upper portion above the straight line should travel beyond the scale. But sometimes, there are some weak waves which spread out into the lower region. This bending is called diffraction at